Hey guys, this is Darvis here. Welcome to GumuOnline. Today I'm going to teach you on how to draw the Lewis dot structure. So we straight on move to the key point of drawing this, and that is the valence electron of each element. So as you can see here in the periodic table, the first row we have alkaline metal. They have one valence electron, followed by the second row they have two valence electron, and straight away we jump to the 10th row where they have 3, 4, 5, 6, 7 and 8 valence electron for the noble gases. And as you can see here in the middle part where I didn't mention earlier is the transition metal. We don't actually apply this formula to them because they are quite complex. Hey, can you just tell me how to draw a Lewis structure for an element first? How we want to draw a Lewis structure of an element. So we start off with an easy alkaline metal here, and that is sodium. Sodium have one valence electron. So what we do here is we only draw it above the name, and we are done here. So the next one is also a common element, and that is oxygen. Oxygen have 6 valence electron. So I don't remember where did I learn this formula, but we put it across here to make the drawing easier. So there goes first electron, second electron, third electron, fourth electron, the fifth and the sixth. So the most important part here is we have to make it clockwise. Okay, so we erase it again and draw it to make it neat. So here it is, the first, second, third, fourth, fifth and 6. And we are done here. So the next one is, oops, stop there. Now give me something harder. Now we move on to single bond molecule Lewis dot structure. Let's take water as the most common, most abundant molecule around us. So as a start, we take the least number of elements in the molecule and place it on the middle, and then hydrogen side by side. So hydrogen have only one valence electron, so we draw there one valence electron and another one valence electron, while oxygen have 6 valence electron, so we draw there 6 valence electron. So the question here is, how are we going to combine all these elements together to form water? So here it is, the single bond, which we name it as binding site. So what we're going to do now is we're going to combine these two binding sites to actually combine these 3 elements to become water. So what I'm going to do now is I'm going to erase the 4 valence electron and replace it with a single point which represent 2 valence electron. So let us just erase everything again, and we draw back the thing. So again, oxygen combined with hydrogen and another hydrogen by a single bond, and the 4 valence electron left for the oxygen. That's not hard. I've seen more bond than that. Shut up, I'm teaching. Since the school syllabus is up to double bond, so we have carbon dioxide here as an example of double bond molecule. So same like previously, we take the least number of element in the molecule and place it on the middle, and oxygen side by side. So oxygen have 6 valence electrons, so we draw 6 valence electron there for this oxygen, and then another 6 valence electrons. So carbon, they have 4 valence electron, so we draw each electron on each side. So how we're going to combine all these 3 elements to form carbon dioxide is by combining 2 binding sides of an element with another element to actually form a duplet arrangement of electron. So what we're going to do now is we're going to erase everything again and draw it back. So same like previously, carbon in the middle, surrounded by 2 oxygen, and then combined by double bond, and then the leftover valence electron for oxygen, and then we are done. Okay, this is seriously the last question. Okay, how about ionic bond? For ionic bond, we use sodium oxide as an example. We know that sodium is located in the left side of the periodic table, which means it's a metal, while oxygen is located in the right side of the periodic table, which means it's a non-metal. So as we know here, metal is positively charged, while non-metal is negatively charged. So what actually happened here is sodium will donate off its valence electron to oxygen to attain duplet arrangement. How does it work here? 1 oxygen with 2 sodium. So sodium have 1 valence electron each. Okay, so and oxygen have 8 valence electron. So what actually happens here is sodium is positively charged and it donates off its only valence electron to oxygen, and eventually oxygen will receive 2 valence electrons from both sodium, and sodium will lose its only valence electron. So now that both element is in ion state, they can combine to form an ionic bond. So since sodium has already lost all its valence electrons, so we don't have to draw it again, while oxygen still have 6 valence electron and extra 2 valence electron from sodium. So I just like to use different color to actually show that oxygen receive an electron from sodium. And what's the difference between covalent bond and ionic bond is ionic bond, to draw it we use brackets and we show the charge of each element.